You literally put 2.7.
All right, so number 6, navigation.
Oh, that was funny.
Lucy, you all right?
Yeah.
All right. Let's stay focused. I know you want to be out of here. I don't understand that at all, but I know you want to. But we need to get this done. So 2 planes flying together in formation, take off in different directions. So here's the airport. One flies due east at 350 miles an hour, and the other flies east northeast. So remember, that means here would be northeast. Would you agree with that? That's northeast. So this is east northeast. And that angle right there, I'm gonna go ahead and make that dark. This angle right here is 22.5. Right? All right, so what's happening? How far apart are the 2 planes 2 hours after they separate, assuming they fly at the same altitude? So, okay, this guy going due east is going 350 miles an hour for 2 hours, so this is 700, right? And this guy is flying 380 for 2 hours, so that one is 760. Is that math right? And the question is, how far apart are they? Do you see a triangle? You're trying to find a side of a triangle. You have 3 options to find a side of a triangle. You have SOHCAHTOA, law of sines, and law of cosines. That's it. SOHCAHTOA isn't going to work because I do not have a right angle. So I'm either going to use the law of sines or cosines. Which one do you think appears appropriate in this case?
Law of cosines.
Law of cosines. Because remember, to use the law of sines, you have to have a pair, and I don't. So this is going to be a cosine problem. Now here's going to be cosine 22.5, and over here is going to be x squared. Right? And in the middle is going to be 760 squared plus 700 squared minus 2 times 760 times 700. That's your law of cosines. And the good news is we can just type that right in and take the square root, and we are going to be done with this problem. How many miles did you come up with? Yep, 290.85 miles, perfect. All right, everybody okay with that guy? Yes, Mrs. Ford, I'm okay.
Yes.
Thank you. Okay, now, next, we have a circle with a sector cut out of the circle. This is 5. This is 7. And would you agree, guys, that this is also 5 right here? Okay. And our job, okay, so a segment of a circle is the region enclosed between a chord and the arc. So this is called the segment right here. That's called a segment of a circle. And we want to find the area with a 7-inch chord in a circle radius 5. Okay. So we want to find the area of the part that I shaded. Okay? Now let's talk about what your strategy might be for that. George?
You basically have a square in the middle. You find the area of the square, area of a circle, subtract the area of the circle, then
Okay, I love your thought about, subtracting stuff. I'm not sure about the whole square thing. Let's look at this for a second. This is called a sector. A piece of pie is called a sector. If I could find the area of the sector and subtract the area of the triangle, that would give me what I want, right? So I think that's gonna be my strategy. So I'm gonna find the area of the sector, and I'm gonna subtract the area of the triangle. Okay, so there's a hand up back there. What's going on? Lucy?
For the area of the triangle, do you have to find the altitude?
No, we don't.
You don't?
No, we don't. Because we have one of the coolest things ever in the whole wide world. If we know all three sides of the triangle, which we do know, we can find the area of the triangle using Heron, well, we call it Hero's formula, Heron of Alexandria. We're going to use Hero's formula to do that. So, the area of the triangle, okay, Lucy, I didn't mean to shoot you down. You could drop an altitude, it's going to be way more work, don't want to do that. I'm going to use Hero's formula if I know all three sides. So, the area of the triangle is a big radical. What goes under the radical? Well, I add up all the sides, that makes 17. Half of 17 is 8.5, so I start with 8.5. And then I take 8.5 minus each side. So 8.5 minus 5, 8.5 minus the other 5, and 8.5 minus 7. So I just multiply those all together. And take the square root of that. Did you get basically 12.5? Yeah. So that's the area of the triangle. So now I need to find the area of this thing right here, the sector. Now, I already know that the area of the whole circle is 25 pi. Would you agree with that? What I'm looking for is a fraction of that, like, I don't know, 15, 20 thirds of it or something, you know, I'm looking for a fraction of it. In order to figure out what fraction of it I had, I really should know this angle. It would be helpful to know that. For example, if I found that angle and it turned out to be 90 degrees, it's not, but if it turned out to be 90 degrees, then I would know that this is 1/4 of the whole circle, because 90 over 360. So I just need to know what that angle is, and then I will know it's that many 3/60ths of the whole thing. Agreed? Or if you want to do it in radians, you can, and this would be 2 pi. It's that much of 2 pi. So let's look at the situation. Can I find this angle right here? You bet I can. How do I find angles of triangles? Law sines, law cosines, SOHCAHTOA, right? Not a right triangle, so I can't use SOHCAHTOA. Shall I use the law sines or cosines to find that angle? It's going to be the law of cosines. So I'll call that angle X. What's my law of cosines going to look like? 7 squared on this end, and cosine X on this end, and then 5 squared plus 5 squared minus 255 cosine X. We talked about this yesterday. We have to be careful, don't we, when we type this in? have to be careful. Don't just start randomly combining all this, you can't. Alright, so see if you can do that and figure out what angle X is. Shout it out if you get it. 88.854. Don't forget you're going to have the second cosine to find that angle. Now, this is 88.854 3/60. So I have that whole thing on my calculator, so I'm just going to say divided by 360. And then multiply that by 25 pi. And I got the area of that sector to be 19.38. Did you? And we already figured out the area of the triangle was 12.5. So the area to our answer, our segment, this is called a segment of a circle, I got 6.88 square inches. Okay, woo-hoo, one more, here we go. A parallelogram has sides of 16 and 19. Okay, everybody knows what a parallelogram is, right? Has sides of 16 and 19 and an angle of 28. With me? Find the longer diagonal. Okay, so clearly, when you look at the picture, you've got this diagonal and you've got that diagonal, and that one is longer, right? So I'm going to go ahead and draw that one in. This is my longer diagonal. Two things we need to make sure we touch base on. Number one is that diagonal does not bisect the angle. There was a god-awful chapter in geometry, my least favorite chapter, about quadrilaterals. All kinds of rules about what does what and what kind of quadrilateral. The only time we bisect those angles is if we have a rhombus. We do not have a rhombus. So we know nothing about these two angles. Don't make any assumption about those two angles. Second thing, we do know in a parallelogram, because these lines are parallel, we know that angle and that angle have what relationship? Supplementary. So I automatically know if that one's 28, I know this one is 152. And that's actually the one I need anyway. I don't need this 28, because if I'm finding this diagonal, the blue diagonal, do you see a law cosine situation there? So here we go. X squared cosine 152, 16 squared plus 19 squared minus 2, 16, 19. Type it in, square root it, and that is going to be our longer diagonal. Don't forget to square root it. 33.97 is what I got. Did I do that right?
Yeah.
That's what I got.
And that is an area, not area, it's a length. So if I had units, like if I knew these were inches, that would just be inches, right? with that? All right, that homework will be due on Wednesday. That homework is due on Wednesday. So 2 things now I want to do. I'm going to hand out a little practice quiz. Because the next class we have, we're going to have a little quiz. And this quiz is going to be over. 5-5 and 5-6. Which is very fresh in our minds, so we're going to practice it right now. And whenever I see you again, next time I see you, you figure it out. I don't think I see you Tuesday. I think it's Wednesday that I see you. Okay? Not that. All right, let's go through that first. Let's do that first. And then I'm going to give you a review sheet. Because now we got to start thinking about a test after we get through this quiz. So here we go. Let's look at the practice quiz and see what's on it here. How many triangles are possible? All right. If my 3-year-old grandson gets asked that question, the answer is going to be, he's going to guess. And what's he going to guess? Either 0, 1, or 2. All right? He's just going to guess. You're not going to guess. You're going to try to figure it out. So, I need to know something else here. Oh, and it's 10. Okay. All right. Law of signs. Kids, you can't stop yourself. When you see this right here, you just immediately think, oh, law of signs. Sine 63 over 10 equals sine, I guess, n over 8 or 9. All right, so let's figure out angle n. What'd you get for this angle? 53.31. So I know, because I got an answer, that there's at least one. If there is a second answer, that angle would have to be the supplement of the first one. Emma's back there shaking her head no, because too much, right? And doesn't match up. It's just bad all the way around. That's bad. So how many triangles are possible? One triangle possible. All right, find the largest angle of this triangle. All right, we're going to find the largest angle of that triangle. So again, we're thinking either law of sines or law of cosines. Which one is it?
Law of cosines.
Law of cosines. Largest angle would be C. So if we want cosine C out here, then we're going to have 8 squared over here, right? And then in the middle will be 5 squared plus 6 squared minus 256. Well, we did one of these just a few minutes ago. Go ahead and type that in and see if you can get your answer. Everybody got it?
92.87.
Thank you, Julia. You keep volunteering. I love it. Thank you very much. 92.87 degrees. Kids, we gotta be able to type it in our calculator, so if you're not getting those answers, you need to be asking some questions. Yes?
Wait, so you do all the, you do all that and then you divide it, what you, the number you got by the 60, or you divide 64 by the number you got, and then do the inverse cosine?
No. You can't combine all of this, Lucy, because that,
Yeah.
did you watch the video from the day you missed?
It wasn't posted when
Okay, well, it's posted now. Okay. You have to remember, it takes a while to get downloaded and all that, so, yeah, you're responsible for that, so please do watch it. All right, number 3. Number 3. Here we go. We're going to find the area of this triangle. TEF, that's my husband's initials, just in one line. Okay. How do I find the area of a triangle? I can go way back to geometry and do 1/2 base times height, but that ain't gonna go because I don't have a height. So then what are my options? We did one today. We did Hero's formula. But what about Hero's formula? You need to have all 3 sides to do that, because the key to Hero's formula is finding the semi-perimeter, and that means you gotta have all 3 sides. So what's our other way, the cool way of finding area? 1/2 BC sine. So 1/2 side times sine of included angle. 1/2 side, sine of included angle. So I'm looking at this. Okay, wait a second. This is not gonna work either because this requires me to have 2 sides, right? So if I need another side, I will find another side. How will I find another side? Either F or T. How will I find another side? That's gonna be, actually, that's gonna be the law of sines, isn't it? Is that what you said? Yeah. Because don't I have a pair right here? So sine 43 over 10 equals, which one do you wanna find? F? Well, I need your angle F then.
59.
It's
What is it?
59.
59, thank you. We subtracted from 180 to find that. So sine 59
You need to
over
find
F.
F no matter what you do. Because you need it to be included if you find the other one.
Sammy's passionate about angle F. All right, so here we go. So we're gonna find side F. So we're gonna cross multiply and divide. So let's see what we get. 10 sine 59 close parentheses divided by sine 43. I got about 12.57. Is that right?
Yeah.
Now I'm just gonna hang on to that though for a second. It's right here. It's right here, still here on my calculator. If I found side F, then my 2 sides are F and 10, right? So when I find my area, I must use angle 78. Now what Sammy was over there talking about is, somebody was hassling him about finding this angle, but he said I need it anyway. Because if I found side T, then my sides would be 10 and T, and I would need this angle anyway, right? You must use the angle that is between the sides. So, our area is gonna be 1/2 by 10. I'm just gonna put F here because it's in my calculator. And sine 78. So let's not round it off. Let's just, it's right there. Let's just use it. 1/2 times 10 times second answer times sine 78. And what did you get your area to be? 61.47 square units, whatever unit we have in our problem. So, moral of that story is, we got a couple different ways of finding area. They're both very easy. Hero's formula, 1/2 side, side, side. Side, side, side. If we don't have what we need, then we can use the law of sines or cosines to get what pieces we are missing. Right? Okay. All right, so that's what happens if we decide it's Tuesday that we have class again. Wednesday, that's what happens on Wednesday. That is also the day your 5-6 homework is due. So here's a review sheet. Huh? The answers to this are online. Yeah.
I remember this picture. This was the homework. No, that was another.
Why are you so passionate about AS?
Well, because I had already started doing it lab, and I didn't want to like research questions.
Oh, so it's self. Come on.
Honestly, that was helpful because some of them
Okay.
as you saw.
So on Wednesday, we will get back our quizzes and we'll have those to go over and review also. But we also have quite a few problems on this sheet to look at. So I don't care where we start. We got plenty of time. We'll just start with some. I'll kind of check them off as we do them. So what do you think? Where do you want to start? What looks like it might be a little bit perplexing to you? First question is 3F, which is a verification problem. So we know what that means. That means we have to change one side into the other. So, here we go, 3F. Wow. This does look crazy. I wonder what that's equal. Tan minus cosine. All right. What pops into your head as you look at this? Well, what's in the numerator, guys? What's the numerator? The difference of cubes. How do we factor the difference of cubes? So, yeah, yeah. So how does that work? I have little parentheses and a bigger parentheses. What's going to go in the first one? Tangent minus cotangent. What's going to go in the second one? Tangent squared plus tangent cotangent plus cotangent squared. If you have forgotten how to factor cubes, you better remember it. Remember? Take whatever the cube roots are, and we square the first one, we multiply them together, and we square the second one. And then our signs are same, opposite, always positive. All right, oh wait, that's still all over this. All right, what do you notice about that parentheses? Anything? Well, you're gonna have your reference sheet, but I hope you wouldn't need it to notice what about this? What's tan times cotan? 1. Why? Because they are reciprocals. And when we multiply reciprocals, we get 1. So that's a 1. So now in that parentheses, I have tangent squared plus 1 plus cotangent squared. On your reference sheet, it says that 1 plus cotangent squared is cosecant squared.
Oh.
So what's in this parentheses? Tangent squared plus cosecant squared, which is going to cancel with the denominator and leave you with what you wanted. Now, that is a super simple problem if you remember how to factor the cubes and if you're paying attention to your reference sheet, right? Okay, who else? Let's see, so we did that one, okay, and we marked that one. Okay. What else are we doing? All right, suppose I handed you one of these problems to do right now for a grade. Which one would you not want me to hand you? Austin?
4A.
4A. Find all answers in radians. So what does the all answers in radians mean? I know what in radians means, but what does this mean?
101.
All the coterminals. So if pi over 6 is an answer, we're going to say pi over 6 plus or minus 2 pi n, right? All the answers, all around, again and again and again. Okay, now, you have a reference sheet, and I know what some of you are going to do. You're going to say, oh, sine 2x. That's 2 sine cosine. And it absolutely is. It absolutely is. And then somebody will say, oh, I can divide by 2, so sine x cosine x equals 0.25. Absolutely true. But then you're going to say something completely wacko like this. No, that only works with what number? There's only one number that you can pull them apart and set them equal to. And what number is that? 0. Okay, so we gotta have a 0. So then you're here, well, I'll just subtract it over. Okay, but then what are you gonna do? That doesn't factor. This is not the way to do this problem. I'm not saying it's not doable this way. It is, but it's much, much, much harder, and it has extraneous roots. It is so much easier to just say to yourself, there is an angle out there. I don't care what its name is. Call it anything you want. But there's an angle out there, and its sine is 0.5. Well, where does that angle have to be if its sine is a positive 1/2?
Quadrant 1.
It has to be either in quadrant 1 or quadrant 2, right? So whatever the angle is, it's in quadrant 1 or 2 because that's where sine is positive. All right, well, what angle, I don't have a calculator for this problem, so what angle has a sine of 1/2? Pi over 6 and 5 pi over 6. So George says that whatever angle, whatever name you've given it, the angle that has a sine of 1/2 is pi over 6 and 5 pi over 6. So the name we gave it in this problem was 2x. So 2x equals those, which means x equals pi over 12 or 5 pi over 12. Because that was 2x. This is a picture of 2x. But there's another thing you need to think about, because in the first revolution, that is the first time no, I don't think I need to worry about that. Okay, let me see. Let me just double check here for a minute. So those are 2x's. So all of the 2x answers would be these plus or minus 2 pi n. That would be all of the normal answers. So when I divided by 2, it would be these plus or minus just pi n. And I think that's going to cover it. If you feel safer, and the reason I'm kind of pausing for a second is, if you feel safer, you can go back and remember that if we're solving the problem in terms of 2x, in the first revolution, we would actually have to go around twice. So it would be this plus 2 pi, which would be what, 13 pi over 6? And that plus 2 pi, which would be 17 pi over 6. Those are the other 2x values. But if I divide, I'm just gonna, it's included there, so that's good enough right there. But you can also do it this way and list 13 pi over 12, 17 pi over 12, these two plus or minus 2 pi n. All of those plus or minus 2 pi n.
Wait, I'm confused where the 13 pi over 6 came from.
What?
Where did the 13 pi over 6 come from?
Okay, if I'm solving the problem, let's suppose we were just going around one time, just one time. If I'm solving the problem in terms of 2x, then I actually have to go around twice. So pi over 6, and then go around again would be plus 2 pi, which is 13/6. And then 5/6 go around again would be 17. Okay? Now, it turns out that because I'm finding all of the answers and I'm already adding this on, which I would, if I had these directions, I would not be adding that 2 pi n on there. But since I already added it on, then I've taken into account all this other stuff. So you can do it either way, whatever way you want to do it.
So you would include the answer one way around and the other way around, or just when you go twice around? Like when you go once around, you get pi over 6. Would you include that as your answer as well?
Pi over 6 is not an answer. Pi over 6 is a 2x value, so pi over 12 is an answer. These are 2x values. These are angles whose sine is 0.5. So you think of this as a different variable. Think of this as y. So y is these, but y is 2x. So 2x is these numbers. So x is half of those. Okay? All right, what else? What would you miss if you had to do it right now? Or come up with something. Liam?
3a.
3a is another verify. So I need to remember or use my reference sheet. Because I got a formula for this. Tangent of angle plus angle. I have a formula for that. Tangent of angle plus angle is tangent of first plus tangent of second over 1 minus tangent of first, tangent of second. Okay? Now, if it helps you, you can change 3 pi over 4 into degrees, if that's easier for you. 3 pi over 4 is how many degrees? How many is pi over 4? 45. So 3 45s is 135. So if it helps you, you can think of this as 135. So where's 135? Over here somewhere, right? What's the reference angle for 135 or 3 pi over 4? Pi over 4 or 45? So these are 1s and that's a root 2 and that one's negative. So what's the tangent of 135 or the tangent of 3 pi over 4? Negative 1. So my top is tan x minus 1. What's my bottom going to be? 1 plus tan x, because it's minus times negative 1. So that'll be plus. We're done. We're done. Right? Okay, what else? Hey, don't just sit there and stare at me, guys. Okay? Because we're not going to review anymore if we don't need to. If you have no more questions, then I'm done. I know how to do these problems.
Wait, how did you get the 1 minus to switch to 1 plus?
Because this is negative 1. The tangent of 135 is negative 1.
So then, oh, okay.
So it's 1 minus a negative tangent. Lucy?
1C.
1c. When you look at this, you should see a formula. So forget the angles, just look at the pattern. It's cosine, cosine, minus sine, sine. Well, what is that?
That's like cosine.
That's
difference.
cosine angle plus
Yeah.
angle. This is a cosine angle plus angle formula. Right off your reference sheet. So your angles are pi over 3 and pi over 10. So how do we add pi over 3 and pi over 10? Yeah, I'm ready to jump off the cliff here. How do we add pi over 3 and pi over 10? We get a common denominator. Right. So it looks like my answer is simply the cosine of 13 pi over 30. Right? There's a backside too, just FYI. There's a lot in this chapter, guys. Yes.
For section 1, what actually find the sines and cosines?
This is a no calculator section, so that would be kind of tough to do, right? Yeah, no, you're just identifying, simplifying, you're just simplifying. Lucy?
9.
9.
On the back.
Okay, we did, this is in the video you didn't watch.
It wasn't posted yesterday. Okay, actually, I don't know.
Yeah.
When I checked, it
Yeah.
wasn't.
You want to come up and see when it got
No,
posted?
but when I checked, it wasn't. I believe you. It probably was.
Oh, yeah, I guarantee it was.
Okay, yeah, you're right.
I am right. You remember that. I am right. Okay.
It's not a kite, guys.
Kites are my best shoe.
It has a sort of kitey shape, but it is not a kite. This is not a kite. There are certain things that have to happen to be a kite, and it doesn't happen here. So, our job is to find the area of this shape. Liam?
Couldn't you split it into 2 triangles?
Yep. And yesterday we talked about this, that we can split this either long ways or short ways. And that's up to you, it's solvable both ways. It's, I think we agreed yesterday, easier to split it this way because that gives us a right triangle, which are always easier. But again, my caution is, when you draw in that diagonal, do not make any assumptions about these angles. We do not know how big these angles are. Okay, so don't make that assumption. All right, can we find the area of triangle 1? Very easily. 1/2 base times height. So that area is 27. That's a no-brainer. We could also do 1/2 9 times 6 times sine 90. And since sine 90 is 1, you're going to get exactly the same thing. All right, now triangle 2 is a little more challenging because I really know nothing about the triangle except that side. So I need to find some more things about the triangle. So what can I find? I can find my blue line, right? That's the hypotenuse of a right triangle. So that's going to be 36 plus 81, square root of 117. So the area of my second triangle is going to be 1/2 the square root of 117 times 16 times the sine of this angle right here. Because now I have two sides, so I just need that angle right there. Okay, we did this exact problem yesterday. How can I find that angle right there? I can't find that angle right there. What do I have to do, Catherine?
Tangent of that angle would be 9/6.
So I gotta find this angle, right? And then once I find this angle, doing what Catherine said, then I can find this one, but I gotta find this one first. So she said, since that's a right triangle, I'll call this angle X. This guy right here, I'll call him X. She says the tangent of X is 9/6. Is she right? It's a right triangle. So second tangent, 9 divided by 6. And that gives me X, but I really need Y. So I'll do 118 minus that. And now I know Y. Right here, Y. So how do I find area? I take 1/2 times the square root of 117 times 16 times the sine of angle Y, which is sitting on my calculator. And what did you come up with for the area of that triangle?
76.1.
So we'll add that to 27, which was the area of the first triangle. And then the area of the whole thing is 103.18 units squared. Feet squared, inches squared, centimeters squared, whatever it is. That's the area. All right, one more. Let's go.
12D.
12D. A wheel of cheese in the shape of a right circular cylinder is 18 centimeters in diameter. Okay, so I have a cylinder of cheese, and the diameter is 18 centimeters. I like to use radius. So the radius is 9, and it's 5 centimeters thick. A wedge of cheese with a central angle of 15 degrees is cut from the wheel. Find the volume of the cheese wedge. So if we're looking at it from the top, here's the top, and we're taking out a 15-degree wedge. So you understand what we're talking about? You've seen that. It's like cutting up a layer cake. You cut it up into wedges. Okay. let's approach this the same way we did our area a little while ago. What is the volume of the whole cylinder? Here's your cylinder. The radius is 9, the height is 5. What is the volume of the whole thing? Uh-oh, are we having volume of a cylinder? Yes, pi r squared h, that's exactly right. So what is the volume of our whole cylinder? Pi times 81 times 5, which is 405 pi. Now, that's the whole thing. How big a piece are we cutting out of it? 15 3/60ths. So we want 15 3/60ths of the whole chunk. So 15 times 405 times pi divided by 360. I got 53.01. What's my unit? Cubic centimeters. Anybody else get that? Okay. Okay. All right. That's it. Let's get ready for prayer. No phones during prayer. Nobody leaves until I tell you to leave.